Okay, in this video we're going to look at creating electrical energy from power stations and then the model of the atom. So the first one is that we're going to do one power station to show you what you needed to do. So, go away. Okay, for each of the power station listed below, we have to draw a basic diagram. Okay, so wind turbine, I might do the hydroelectric dam. So hydroelectric dam has some water behind a dam, and then that water goes through the dam, goes through the penstock things into your turbine. This is a real basic drawing. You're going to obviously do a lot more care than me. Okay, and so our water flows in through here, turns these turbines, so they start spinning, and then the water will flow out, okay, from there into a river. The turbine will then turn a generator, and then from the generator it goes as electricity out into the wide world. That's just a basic picture of it, okay? So labeling the important things, obviously that's the dam. We have got a turbine. That's the penstocks. That's the generator. And power lines. Okay, now, it says here, draw a label basic diagram. Good. Okay, draw an energy transfer diagram. Okay, so first up we start off with gravitational potential energy, and that's in the water, okay? And then that goes into the kinetic energy of the turbine, okay? And then that goes into you can say the kinetic energy of the turbine and also the generator, okay? And then that goes into electrical energy, okay? What's interesting is the actual water flows through here and then through here. It doesn't really change. More of the pressure that makes the thing go around, not the kinetic energy. So that's why I haven't said kinetic energy of the water at any time. State if it's renewable or non-renewable. This is renewable. Why? Because you don't dig water out of the ground and it disappears, okay? As long as it rains, which will hopefully do for the foreseeable future, then the dam's going to fill up, okay, and it'll keep working. Ones that aren't renewable, coal, okay, once you dig it out of the ground, it's all gone. Nuclear is not renewable, but it'll last a long time because you don't need much of it. But once you dig up all the uranium and so on, we will run out of fuel. And out of those options there, that's it, okay? Gas is not renewable. What is renewable? Geothermal is renewable because you can put the water back down and it'll heat up again from the mantle, sort of the mantle, and then you've got your solar panels, which is just light from the sun, and the wind turbine. As long as you've still got wind, that would be renewable. Okay, now for the other one, draw a label diagram of the classical atom. So inside the atom, we've got the nucleus. So that's the nucleus. And inside the nucleus, we have two particles, protons and neutrons. This is the classical atom that essentially was made by Rutherford. Okay, and then around the outside, we have electrons. Label the electron. Okay, done that. Write two interesting facts about each part you labeled. Okay, well, you could actually say the proton is about 10 to the negative 15. Okay, or smaller than that actually. 18 meters. Okay, so it's quite small. It was 16. So you can look at the size. Next one you can say it's positive. That's probably next question. Oh, that's the next question. It's also made up of some quarks, 3 quarks, okay, an up, and a down quark. The neutron, okay, has also got 3 quarks, but it's up, down, down. It's about the same size. It is neutral. Okay, the nucleus, around about 10 to the negative 15 meters, quite small. It is found from the gold foil experiment by Rutherford. Okay, electrons, very small, 1/2000th of the size of the other things. Okay, it is what we call quantized. The charge on it is quantized, has definite levels. Okay, any sort of Google site will tell you some stuff. Next one we're going to look at is C, state the electrical charge of the electron, neutron, and proton. So the charge for the proton is +1, okay? The neutron's 0, and the electron's -1. So positive and negative. Define and send as the term atom, okay? An atom, smallest building block. Periodic table is based on it. There are smaller particles, okay, but the word atom is based on the idea it's the smallest building block, and we still use it as the small building blocks. We don't talk about quarks in terms of what the materials are and so on, so it's not a common usage except for particle physics. Other parts of the table, the smallest things found in nature? No, because there's quarks, okay, and so on. There's neutrinos, mesons, there's all these different types, muons, there's a whole lot of different types of particles. Most of an atom, and hence us, is empty space in a vacuum. Why do we look solid when we are mostly empty space? Okay, most of an atom is 90.99% or so empty space. So that means we are almost the same in terms of empty space. We just look solid because of, so we might have some atoms in our body, okay, with some small nuclei, pretty much all empty space along here. So what happens when light comes in, it actually just reflects off because it gets absorbed and re-emitted by the electrons. And what we see is the reflection of light, and that's why we look solid. Why do we feel solid? Because of electrostatic repulsion, which we'll look at later.